Hello and welcome everyone. This is Mohammad Izamam from Saimedha Ecet Coaching Center Koti, Hyderabad. Saimedha Koti, Hyderabad is providing a golden opportunity to all the Ecet 2024 and as well as Ecet 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, Saimedha Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. ర్యాంక్స్ గురించి చెప్పాలంటే Saimedha Koti Hyderabad లో every single year we have proven that maximum ranks in all the branches EC, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous Ecet examination questions will be explained by expert faculties. My dear students, gurtu pettukondi, only previous year competitive examination questions korake separate course untadi, pay cheyalsi untadi baita market lo, kani Saimedha Koti Hyderabad lo free of cost we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous Ecet examination questions with which you can understand the level of teaching, the expertise which is there in the Saimedha Koti Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the Ecet 2024 and Ecet 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Hi, hello everybody. Welcome back to the sessions of Ecet PYQs. Now we are going to discuss a topic here called Tacheometric surveying, and we are going to see all the Ecet PYQs that came in this chapter of Tacheometric surveying. So let us start with the very first question. If a tachyometer is fitted with an analytical lens, then what will happen? See, generally when we use this tachyometer, okay, so if you observe the diaphragm here, see, this is a tachyometer diaphragm, and if you observe the diaphragm here, the diaphragm will be seen like this. And two more additional crosshairs will be observed here. Okay, so now this is the diaphragm. This is the diaphragm of a tachyometer. Okay, so what happens when a tachyometer, that means what happens when two more crosshairs are getting added? These two crosshairs we do call it as stadia hairs. And these two additional crosshairs will be bringing the constants. Okay, so what are the two constants that these two crosshairs will be bringing here? That is, these two additional crosshairs that they will be bringing here is an additive constant. And a multiplicative constant. Okay, if you observe here, if a tachyometer is fixed with an analytical lens, so additive constant will be coming, multiplicative constant will be coming here, but he is not asking whether what kind of constants are coming. He will be asking us, see, he asked us like what is the value of this additive constant, multiplicative constant. Remember, the values of additive constant, multiplicative constant are not fixed. Okay, so but generally we will be taking here the additive constant value as 0 and multiplicative constant value as 100. Okay, though they doesn't have any units. So if you see your additive constant is 0 and multiplicative constant is 0, no, sorry, additive constant is 100. Additive constant is not 100 beta, additive constant is 0, additive constant is 0 and multiplicative constant is 100. Fine. So very simple question here. Now let us take the second question. The tangential method of tachyometry uses So what is the difference in between tangential tachyometry and stadia tachyometry? See here, if you observe, so if you observe here, the tangential tachyometry and stadia tachyometry, the tangential tachyometry will be having only a single crosshair. Okay, only a single crosshair will be observed, and for a stadia tachyometry we do know that two more additional crosshairs will be coming here. Okay, so now this is tangential tachyometry, and this is stadia tachyometry. Fine, so two more crosshairs will be coming here, that is stadia intercepts will be coming here, but here no two additional crosshairs will be coming here, so only tangential tachometer will be dealing with only crosshairs. So the reading against all the crosshairs, the reading against top and bottom crosshair, it doesn't have top and bottom crosshair, the reading against the middle crosshair only, a constant intercept on the staff, no it's not the constant intercept of the staff, and reading against all the crosshairs, it is having only one crosshair, so I am eliminating this option also. The only option that is left here is the reading against the middle crosshair only, the reading against the middle crosshair only, so simple answer. Fine, moving further. Tangential method of tachometry is slower than your stadia tachometry, so slower than the stadia hair method. Okay, it's not faster, it's not preferred, no. Okay, so direct answer here. The stadia diaphragm is provided in a theodolite for measuring. See, generally why we are providing the stadia diaphragm here, already we have seen what is the stadia diaphragm. So you can see this is a diaphragm, this is the stadia diaphragm here. So you can see upper stadia hair is there, lower stadia hair is there. This upper stadia hair will be giving a value and the lower stadia hair will be giving a value. Okay, so whatever the value that you are getting from here on the staff and whatever the value that we are getting from here on the staff, so we have to subtract these two values on the staff and we will be able to have a value, and that value is used for finding out the horizontal distance directly. So that's what the point is all about. So see, there is a question here. The stadia diaphragm is provided in the theodolite is only for measuring the horizontal distance directly. So it's not the elevation, it's not the bearing, it's not the horizontal angle, it is a horizontal distance. Okay, that doesn't mean that we are not going to find the elevation or we are not going to find horizontal angles or bearings. We will be able to find out all these also. But the point is here, the stadia diaphragm, that means we are giving a stadia diaphragm to a theodolite in order to find out the horizontal distance directly. So, okay, the more preferred answer here is horizontal distance. Okay, moving further, find the horizontal distance of a tachyometer station point P and the observation point Q with the staff readings of 1.550, 1.330 and 1.110. The instruments are having the constants of 100 and 0.5. So while using stadia tachometry, we will be taking a formula like D is equals to Ks plus C. This is a formula for finding out the horizontal distance directly. Okay, where K is called the multiplicative constant and C is called additive constant, and S is nothing but the staff intercept. Okay, so now what is multiplicative constant here? He gave the instrument and constants were 100 and 0.5. Generally we will be taking the multiplicative constant as 100. Okay, and the value of S is the upper stadia hair reading minus lower stadia hair reading minus 1.110. Okay, plus C, the additive constant value is given here as 0.5. So if you just solve this, 100 1.550, this is 0.044, right? 1.550 minus 1.110, this is 0, this is 4, this is 4, and this is 0, yeah, 0.440 plus 0.5. Okay, if I cancel out this 3000, so goes on cancelled here, so the value comes out to be 440 upon 10, so this is 44 plus 0.5, 44.5, so answer is 44.5, very simple, right? Okay, so moving further, this is only the relation that we have to remember for finding out the horizontal distance directly by using this instrument called tachyometer. Moving further, the tangential method of tachyometry is already we have discussed here. The tangential method of tachyometry is slower than the stadia hair method. Tangential method of tachyometry is slower than the stadia hair method, it is slower. Okay, already this question came here. The tangential method of tachyometry is slower than the stadia hair method. Analytical lens provided in a tachyometer is, see, whatever the analytical lens that we are providing for a tachyometer will be of a convex lens. It's not even plano convex lens, it is only the convex lens that we are going to use in a tachyometer. Fine. In stadia tachyometer, the ratio of focal length to the objective of a stadia intercept is known as, see, the relation D is equals to Ks plus C. Okay, where K is called the multiplicative constant, where the K can be found out by using this formula F by I into S plus, where C can be taken with the formula F plus D. Now the question is all about, in stadia tachyometer, the ratio of focal length of an objective to the stadia intercept is nothing but multiplicative constant. So 1 will be the answer for this question, simple. Okay, moving further. For a tachymeter, the fixed interval between the stadia hairs is 4 mm, the focal length of the objective is 24 mm, and the distance of vertical axis to the instrument from the optical center of the objective is 15 centimeters. The multiplicative constant, so we do know, already we have seen previously, D is equals to Ks plus C. This is a relation finding out the horizontal distance directly. Okay, where K is equals to F by I into S. Okay, plus C is nothing but F plus D, that is additive constant. Now he is asking the multiplicative constant here. So multiplicative constant can be found out. This is multiplicative constant. Multiplicative constant that is f by I, and if you observe the focal length here, the fixed interval between the stadia hairs is 4 mm. The fixed interval between the stadia hairs is 4 mm, and the focal length of the object is 24. So this comes out to 4 6 24. And again, what he said, the multiplicative constant of the tachymeter. See, the focal length of the object is 24 mm and the distance of vertical axis of the instrument from the optical center. So the multiplying constant of a tachymeter is only this is only 6, but the option is not there here. I think for a tachymeter, the fixed interval between the stadia hairs is 4 mm. The focal length of the object is 24 mm, and the distance of vertical axis of the instrument and the optical center, that is f plus d, but he is asking only as he is only asking the multiplying constant. So multiplying constant is nothing but f by I. So that is 24 upon 4 comes out to be 6. The answer is 6 here. That is there is no options. This answer is 6. Okay. Let us move further, finding out the horizontal distance. That is the total horizontal distance. This is 6 into S value is not given, right? So S value is also not given here. So the only multiplying constant is f by I. So we can take the value of 6 directly here. Okay. So both were in terms of mm. So I have taken both in terms of mm. Okay. So mm goes uncancelled. So as it is constant, it doesn't have any units here. So 6 is the answer for this question. Okay. Moving further. A tachymeter was set up at a station P and the observations were taken on the staff held at Q. The vertical circle reading being 0. The readings were 1.980 and so the values are given here. So just we are supposed to find out the horizontal distance from this relation D is equals to K space C. Okay. So the K value constants are already I think we have solved this. No, we haven't solved this. Okay. So this is 100 into S value being 1.980 minus 1.340 plus C is 0.5. So 100 into this is 0, this is 4, this is 6, 0.640 plus 0.5. Let me cross check this 00448 6789. Fine, 1 minus 1 0. Fine. So this comes out to be here. This is 1000. Okay, so 0 0 goes and cancelled. So this is 64 plus 0.5 comes out to be 64.5. 64.5 will be the answer for this question. Simple, right? Okay. So moving further, the diaphragm of a stadia theodolite is normally fitted with two additional crosshairs. They are nothing but the stadia hairs. These two additional crosshairs are nothing but stadia hairs. Okay, upper stadia hair and lower stadia hair, we do call it as. Okay, so moving further. Subtence bar method. A subtence bar is an instrument used for measuring horizontal distance in. So generally subtence bar we will be using in undulated areas. That objective question. The stadia method is used to determine the horizontal distances. So more preferably we have to give this answer called horizontal distances. The method of tachyometry commonly used is, so generally when we are carrying out this tachyometric work, okay, we will be using fixed hair method. We won't choose movable stadia, we won't choose substance stadia, we won't choose tangent system. Moving further, a branch of surveying in which the horizontal and vertical distance of the points are obtained, instrumental observations are known as a branch of surveying in which horizontal and vertical distances can be found by using this instrument called tachyometer. So we can simply answer that question as tachyometric surveying. Fine. So these are all the questions that came in PYQs for this topic called tachyometric surveying. Okay. All the best.
So my dear students, for Ecet 2024 and Ecet 2025, Saimedha Koti Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi Saimedha Koti Hyderabad in this very week, guys. In this very week only we are providing the maximum concessions. Concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, ఉంటాయి, విత్ మెటీరియల్స్, వితౌట్ మెటీరియల్, ఆన్లైన్ కోచింగ్, టోటల్ మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద Saimedha Koti Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous Ecet examination questions. I wish you all the best. This is Mohammad Inzamam signing off.